Guys, sorry about that. Let's look at this and broken into its components. So I, again, have my hockey puck, and we had the two forces that were applied to it. So I broke that up. Here's the first force, 20 degrees below the x-axis. Second force that was applied to the hockey puck, 60 degrees above the x-axis. I know the hypotenuse of both of those triangles, so I need to figure out, ultimately, the magnitude and the direction of the puck's acceleration. But when I do that, I have to think about what is the sum of the forces in the x direction, and what's the sum of the forces in the y direction. And to do that, I'm going to need to figure out what this first force is in the x direction and what this second force is in the x direction. So I could find that if I did, let's say, the first force was 5 newtons at 20 degrees. So if I'm thinking about my x direction, so my x would be 5 newtons for my first force. I have 5 newtons times cosine of 20 degrees. So this would be for my first force. And if I'm thinking about the sum of these forces in the x direction, I want to add that to my second force that's acting in the x direction. So that one would be the hypotenuse 8 newtons times cosine of 60 degrees. So I have 8 newtons times cosine of 60 degrees. Okay, I want to do the same thing in the y direction. Because remember, I need to find the sum of those forces. I need that net force overall. So sum of the forces acting in the y direction. I have for F1, which would actually be pointing, it's 20 degrees below the x-axis. So I would do 5 newtons times cosine of a negative 20 plus, same thing here for my second force, which would be 8 newtons times sine of 60 degrees. Okay, so if we do those, we should get 4.7 and 4.0. So the net force in the x direction should be 8.7 newtons. And the net force in the y direction should be 5.2 newtons. Okay, so now that I know the sum of the forces in the x direction, the sum of the forces in the y direction, we could actually go ahead and solve for the acceleration in both of these directions as well. Because that problem said that the hockey puck has a mass of 0.30 kilograms. And since we know its mass then is 0.30 kilograms, we know that Newton's second law is force equals mass times acceleration. I have my force. To get acceleration then, if I divide it by the mass, 0.30 kilograms, 0.30 kilograms, then I'll go ahead and get my acceleration. So let's do that. So if I take 8.7 divided by 0.3, we would get 29 meters per second squared. And if I did 5.2 divided by 0.30, I should get 17 meters per second squared. So I know the acceleration in the x direction, and I know the acceleration in the y direction. But now they're asking me, though, to find that overall acceleration, its magnitude and its direction. So if I wanted to find that overall acceleration, I could do squares of these and then adding together in square root. So I'd have 29 squared plus 17 squared, and then take the square root of that. If we do that, we should get 34 meters per second squared. So there's my magnitude of the acceleration. But I also need to find direction. So to find direction, we could do inverse tangent. And we would want to do our y over our x. So we would have 17 over 29. So if I did that, I would get 31. My theta should be 31 degrees. All right, so let's do another one. Okay, so now we have a force of 10 newtons is applied at an angle of 30 degrees to the horizontal on a 1.25 kilogram block, initially at rest on a frictionless surface. So we want to know what is the magnitude of the block's acceleration, and we want to know what is the magnitude of the normal force. So initially this block was at rest, but we're applying some force of 10 newtons at an angle of 30 degrees, and it's going to be this applied force here that's going to cause that block to move. So it's at rest, but then it will move. We're assuming no friction, and right now I just want to know the block's acceleration. So let's draw a picture of this. Okay, we have